Okay, so we got our first Final 14. Go ahead. So, introducing the team members of EcoAssists from Georgia Tech, a senior in mechanical engineering, Michael Hooper, a graduate student in mechanical engineering, Dae-Kun Pei, and a senior in mechanical engineering, Kyung Young, and finally, an assistant professor in mechanical engineering, Michael Leamy. Take it away, guys.
There are 25 million children transported on more than 480,000 school buses around the world. But the question is, what is that change? The standard American school bus has a fuel economy as low as 3.8 miles per gallon. On the other hand, as illustrated on the figure, the diesel price has shown increasing demand over the years. Note that every single extra hundreds of thousands spent into fueling this transportation, the same amount is extracted from the welfare of public education or these school children. Besides, the typical diesel engines release large amount of toxic pollutants into the air right around the premises of these school children, which cause major respiratory illnesses. These factors, along with new emission standards, create a tangible need for a clean technology that offers increasing efficiency in heavy vehicles while reducing operating costs and dependence on fossil fuel. And this is exactly when EcoAssists come to play. EcoAssists started out as a research project at Georgia Tech funded by a $50,000 for company grant. Basically, I would say we're just a bunch of geeky engineers aimed to make real difference in addressing the urgent community need related to sustainability. Essentially, we're developing a hybrid technology that updates traditional buses into hydraulic hybrid retrofits, while SIX improves fuel economy and reducing the children's exposure to harmful emission. This is the list of founders and advisory board. I'm Kyung Young, and I'll serve as the Chief Executive Officer. This is Dae-Kun Pei, he will be the Chief Technology Officer. Michael Hooper, Chief Operating Officer, and amongst us, Dr. Michael Leamy, who will be served as the Chief Scientific Advisor.
A hybrid vehicle is any vehicle that receives its power from two or more sources. A hydraulic hybrid receives its power from an internal combustion engine as well as a hydraulic pump motor. Hydraulic hybrids are considered much more efficient than a gas-electric hybrid because there are fewer losses from energy conversions. There are currently two different systems on the market. Eaton Corporation has developed a system for UPS to be used in their fleets, and Altair Inc. has recently released a transit bus for use. Both these systems are considered series systems. A series system hydraulic setup replaces the transmission with a hydraulic pump motor. The hydraulic pump motor then turns the rear wheels hydraulically. While effective, this system requires the platform to be engineered from the ground up for use with these components. EcoAssist system uses a hydraulic technology utilizing a parallel system. The big difference with the parallel system is that we supply and retrieve the energy through the existing drivetrain. EcoAssist system uses a transfer case which is connected through a drive shaft to the hydraulic pump motor. The pump motor is controlled with an ECM that responds to driver's inputs. When the vehicle is braking, the pump motor is switched to pumping mode and forces hydraulic fluid into the high-pressure accumulators, storing the energy. When the vehicle is ready to accelerate, the hydraulic fluid is released from the accumulators, flows back through the pump motor, which is then switched to motoring mode, turns the transfer case, and sends additional torque to the rear wheels to accelerate the vehicle. Our simulations show conservatively 24% increase in fuel economy. And in addition to this fuel economy gain, the users can also expect an extended brake life and a significant reduction in pollution outside the vehicle.
Shown here is the bus vehicle power sources broken down by percentage. We are only interested in the trends. As seen in the green box, the pure diesel power fuel bus has declined. The market share of it has declined over the years. Whereas the alternative fuel type like CNG and hybrids, they are growing steadily over the years. If you look closely just on the hybrid column, there is a jump of 2.3% to 7%. This clearly indicates there's an ongoing demand for a more sustainable bus fleet. Also to be noted that there are even more government green incentives to foster the development of such technology. Market-wise, we positioned Atlanta Public School as our strategic partner. And their interest and support in our work dates back to the fact that our current working bus prototype is detonation. That's why the 400 initial bus fleet will be our initial target market. I would like to also mention on the fact that our current Mayor Kisingri is also a great advocate for sustainable technology. With the success story in the ATS system, we'll expand our market to the state of Georgia and the neighboring states, and finally nationwide. Bear in mind of the fact that the potential markets half a million of school buses in just US alone.
To tap into this enormous market, we have developed a business plan that have three distinct phases. Currently, we have our technology outfitted to a school buses and it's up and running with hydraulic power. To be able to take this onto the road, we have to test the prototype extensively for operability, reliability, and performance. Then we have to optimize our components for cost and efficiency. Lastly, we have to work with third party for certifying design and road use. This will allow us to start upgrading the bus fleet of Atlanta's public school system. During this period, we will explore our funding sources such as the Clean Fuel Grant and Small Business Innovation Research Grant. Moving on to the second phase of our commercialization plan. During this period, we seek patents and we secure patents and trademarks for our product. We will expand our operation outside the greater Metro Atlanta area, and we will expect growing demand for our technology. That's why we will have to increase our staff size and undergo capital expansion to give that demand. Lastly, we expect during this period we will become profitable and self-sustaining. And our goal is to remain a comfortable profit margin by keeping our costs down while maximizing our customer spend. Lastly, once we have enough demand for our product, then we have to leverage that demand by going to heavy vehicle manufacturers. Heavy vehicle manufacturers historically has remained conservative and resisted changes, but they won't be able to do that when there's such large demand for our product. That's where we're coming. We will license our product for them to use as on the OEM level. And we serve as clean energy consultants and on-site outfitters to these OEMs. In summary, commercialization of our technology will meet the market's need for cleaner and more fuel-efficient technology in heavy vehicles. And we're strategically partnering with APS to do this. Finally, our business model is to enter the market both as outfitters and consultants. This way, the long-term viability and profitability of the company will be ensured. Thank you very much, and I would like to open up the floor for questions.
Testing. Okay, this works. Have you looked at the payback period for your device? So, for example, it costs $14,000 for the unit, plus I assume there's some cost to have it installed. How long does it take to actually save that amount of fuel for the customer?
Good question. This is exactly how we price our product. We expect the payback period to be 5 years for the school bus system when they outfit our bus, because we have a 24% fuel economy increase. And with that margin, you can expect with the current diesel price, the payback in 5 years.
5 years? Okay, thanks.
Could we go back to your last slide, the one before this? I'm wondering sounds like your outfitters to, is it a retrofit market or a new OEM part of the, I'm a little unclear if you're an aftermarket installer or you do it alongside the build of the vehicle in the first place.
It's a little bit confusing, and the reason is because our first goal is to get these buses implemented into a small fleet, an APS, in a smaller number. Then once that technology is proven and they've been in fleet, move to the OEMs. Long-term wise, it'll be a lot simpler for the school buses to adopt this technology if the OEMs are supplying it. So the initial phase is going to be outfitting ourselves, and then we'll move directly to OEM once the technology is proven and in service.
And the second part of the question is, why the selection of school buses that involve transport of kids? I wondered why you didn't select a different type of vehicle that it doesn't have a potential safety overhang issue with human transportation.
The model that we're using, the parallel system, actually isolates our system from the stock drivetrain. So if there's some sort of failure in our system, they can always revert back to the brakes that are always there. A big reason why the school bus is such an ideal candidate to see big gains is the drive cycle is stop and go. You know, the school bus starts, stops, and most of this is between 25, 30 miles an hour max. Another reason is the hydraulic hybrid setup does take a little bit of space. You've got the pump motor, you've got the accumulators. With the school bus, that space is completely unused. If you look at something like a refuse truck, they also have an existing hydraulic system, so you might actually get into space conflictions that just aren't there with the school bus. Pretty much any frame and body style school bus has room for this setup.
I actually was on the board of a hybrid bus company, so at one point I'd love to talk to you guys in more detail. But two questions. Barriers to entry, what do you think about that, and why you guys? What is it about the team that you think is going to ensure your success?
The barriers to the entry wise, we are the pioneer. We are the first market, and we want to secure the whole market.
Team. What makes us a good team?
What makes a good team?
What are your skill sets? Why are you guys going to succeed at this? What is it about you three?
Well, our technology is made to retrofit on the existing platform. So the current owners of these buses, they don't have to go out and buy a new bus within our technology. So our barrier to entry is much lower than other architectures out there, which will require the redesign of the entire drivetrain.
And to answer the second part of the question, I don't think you quite got it, but our team, the three of us, we each kind of bring a different background. Deacon's our graduate student. He's extremely sharp. There's not much in terms of formulas and calculations that he can't figure out. Kyung, obviously, he's a good public speaker. He's not scared to engage. He's going to be very good in sales. I personally have a background in mechanical, not just mechanical engineering as a student, but mechanics. I actually used to work in a engine importing business and do fabrication and race preparation on the side, and through a small business of my own. So I have more of the actual hands-on background.
Hi, I'm interested in knowing more about how you're selecting your VOC, your voice of customer. So you've selected the school buses because of relationship in Atlanta, and then your trademark and IP. So I'm interested first in your voice of customer. Have you been to any of the other potential school districts or transportation companies that you think are a logical market for you? And if so, are they consistent with the thought process and purchasing behavior of Atlanta, or is there something unique about Atlanta? Why don't we start with that one?
This market we're entering in, we are trying to get a less common hybrid technology to the market. That's why we're focusing on a very niche target. APS has been our partner on this project for a long time. That's why we're focusing all our resources to secure the contract. But I don't see why the same logic could be applied to Cobb counties, Gwinnett counties, and we haven't approached them directly, but we know that they will like the idea. But APS wanted us to have them to be the first.
How do you know they're going to like the idea?
Because they have clearly indicated their interest. They have donated the bus in the first place, and they have eagerly asking for updates. And we are now negotiating with insurance partner, which is the American Southern Insurance. We're trying to coming up to something.
Have you talked to the OEMs?
The OEMs, no. We haven't talked to the OEM directly, but we have talked to some of the people who work in the OEM. All these heavy manufacturers, they are very conservative market. They won't do something big. They won't introduce a big technology change unless there's a clear demand that this is what they want, this is what the market wants, this is what all the school system wants to have in their bus. So what we do here is we first implement a few bus leads into the ATS system and let the words of mouth spread.
Excuse me, this question is more along the lines of the question I need to get to. What is it about this design technology that is patentable, that could not be essentially copycatted by somebody else? Is there anything unique about the components or other aspects?
The most important thing is design. The parallel design itself is very specific. It's specific for bus, just for bus. And we have codings. I've developed the codings, the program, and we have also developed the whole drawing of the system, sizing, and those can be patented.
And simulation.
And the simulation, of course, the simulator, the multidisciplinary simulation developed by Deacon.
So have you looked into having a patent, to have someone independently take a look at that?
Yes, we definitely look into that because our ultimate goal is there is no possible way that we can outfit 500,000 of buses out there. We're thinking of licensing out. That's one of our revenue model.
And then, so how long does a bus last? So you said the payback was 5 years. Typically, how long does it last? And are there any additional maintenance costs that come with your technology that aren't with other competing technologies?
The hydraulic system is, I'm not going to say maintenance free, but in comparison to the rest of the vehicle, relatively maintenance free. It's going to need fluid changes and such. There's always a chance for leaks to develop, but it's pretty simple in terms of the actual components that make it up. And all these components should outlast, or at least last as long as the rest of the components on the bus, like say the diesel engine that provides the main power. In terms of the vehicle turnover, really depends on the school district. Some school districts move the buses out in as short as 10 years. Some keep them 20 years. So that just depends. But again, if you compare the pump motor, which is probably the most expensive piece and has the moving items in it, it's going to last just as long as your typical diesel engine. Same thing goes for the transfer case that diverts the power.
Also, I'd love to note that every these school buses, we're looking at 400, 500, even 1,000 of buses. They already have existing maintenance team in every of these public school system.
How do you get your product manufactured if you're not the manufacturer? You're going to license the design to have you selected or looked at your manufacturers if you're going to license so that you know what kind of manufacturers you're pursuing?
Yeah, we are currently looking at Navistar and Bluebird. They are the two of the biggest manufacturers of school buses.
And they would actually manufacture your component systems, or they would be sourcing them from somewhere else?
Our component, the major one is the pump, which is manufactured by Eaton, and they don't manufacture any bus component. As a matter of fact, all our components are off the shelf, which makes it the reason why it makes our design proprietary.
And the pump doesn't just come from Eaton. The Clean Industry also offers a pump for our current design. That's actually, Dr. Limi has just secured another grant from Clean Industry because they want to sell up the pump to us. They are very interested in what we are doing here.
I think just to follow up on that, in terms of equipment that's specific to the bus, we've got some bracketry and some simple hardware, some hydraulic lines. This kind of stuff could be contracted out and isn't necessarily going to take a special skill set. It's just industry style parts, I guess you could say. The stuff that makes it run that we hold is going to be the coding and the control module. The rest of it can be assembled from general manufacturing sources.
require engineering the entire drivetrain, I guess, because powertrains are important. So what kind of a fuel savings are we talking, comparing those two? You said you save 24% mile per gallon, whatever that works out to.
You meant series compared to parallel?
Yes.
Yes, series could have a greater efficiency, but it also requires extensive modification. We are looking at EPA produced a report somewhere around 35 to 40%. It was tested on the Detroit route for the UPS delivery truck.
And what does that cost?
Keep it short, 5-second answer.
Okay, 7,000. 7,000 is to redesign the whole structure redesign. We are talking about taking things out and putting it back in.
It's 120,000 added to a bus to make it a series hybrid over a standard diesel-powered vehicle.
Okay. Sorry, we're out of time. I'm sorry. We don't want to make it. Thank you very much, EcoAssist. Give EcoAssist a hand. Nice job, guys. Nice job.